Thanks for listening. This is Brian Hurley from Business Performance Improvement. The podcast Lean Six Sigma Bursts are short lessons, comments, Q&A, and insights. If you have a question, send your question through the Anchor app, and we might feature you on a future episode. Or contact me at biz-pi.com.
In today's podcast, I wanted to talk about some sustainability work I've been doing and how it ties into some Six Sigma concepts. So I'm working with an organization right now, and they are looking at their sustainability results, and there's a scoring mechanism that their customer is asking them to work through. So they go through and answer a bunch of questions about things that they're doing around environment, things they're doing with their workforce, things they're doing in the community, and they have to achieve improvements in those scores. And so we've gone through and really tried to study what the scoring mechanism looks like and how those points are assigned, and then look at the gaps and try to figure out how to prioritize the areas that we can focus on that will increase their score the quickest and easiest. One of the things that they're looking at is setting a goal around their electricity usage, because that's one of the biggest drivers of their carbon footprint. By digging into that electricity usage, we can uncover what is the current trajectory of their usage going forward to try to understand how much do you need to reduce by, because over the last couple of years, they've seen an increase in that electricity usage. So if you're trying to set a reduction goal and your trajectory is going up, then you not only have to improve by the trajectory of growth that you're seeing in electricity, but then also bring it down an additional amount. One of the techniques to do that is a regression analysis, where you can take your output, which is the amount of kilowatt hours used each month or each year. Usually you want month at least, because that's more data points, and each month is different from a seasonal perspective. If you could do weekly usage, that'd be even more data points to evaluate, but then you have to track data at a weekly level. So monthly seems to do okay, but then that means you need about 2 or 3 years worth of data to get a good data set to analyze. And I've done this before at other sites, so pretty familiar with that. So then the next step is to figure out what are some of the inputs that are good at predicting or modeling or describing how the fluctuation in the kilowatt hours changes month to month. So the obvious things would be like how many employees are working in the building that month, how much work is being done, like how many working days that month are people at work, because some months have more working days than others depending on holidays and weekends. Also, how many units or widgets or things are being processed. That might give an idea around usage. If you're dealing with manufacturing equipment that uses a lot of energy, then obviously if you use that equipment longer or produce more things, there's probably more energy being consumed. The other thing is the seasonal effect of temperatures, especially in a climate or area that goes through all 4 seasons. Then you're going to see ups and downs throughout the year depending on the outside temperature. So you can go online and you can download the nearest weather station data, so you can get temperatures for that location or a location very close to that. That's all the stuff we've gone through and uncovered. And sure enough, like in a lot of facilities, the outside temperature is a big factor in your amount of electricity usage. So as we've talked through that, I think the initial thought client had was that, well, there's nothing we can do about that. That's outside of our area of influence, right? Because we can't change the weather. And that's true. You can't do anything about the weather. However, let's look at it from a process mapping standpoint. And that's one of the things that you want to think about whenever you're doing any kind of improvement work is, what is the process? It's not what the outside temperature is doing. It's what does your building do as a response to this outside temperature? Think about this. So let's talk about the summer when it's warm. The sun is shining onto the building. If there are any trees in the way, that will block some of the sun from hitting the building. Okay, so one thing we could look at is what is the vegetation and the trees surrounding the building, and is that doing anything to slow down or block or prevent sun from hitting the building? Then it hits the roof, and if your roof is dark, that could attract and absorb more of the heat. If it's lighter or white, it might reflect some of that heat. So we look at the roof. It also comes through the windows. So we would look at the efficiency of the windows. How well does it reflect light, and how much does it absorb or bring into the building? The more it allows through, the more heat it allows through, the quicker it heats up the inside of the building. The other part of the roof is insulation. So what is the material that the roof is made of, and what insulation is in place that will slow down or block some of that heat from getting down into the office area or in the manufacturing area. So that's another area to look at, insulation. And so we're basically process mapping the flow of heat coming into the building. So once the heat goes through all these different steps, then it gets to the workspace. And then what that does is it heats up the area and the air in that workspace, and eventually it increases the temperature. Let me pause for a moment to tell you about our sponsor, Creative Safety Supply. They are a great resource for free guides, infographics, and continuous improvement tools. I recommend starting with their 5S guide. It includes breakdowns of the 5 pillars, ways to begin implementing 5S, and even organization tips and color charts. From red tags to floor marking, it's all there. Download it for free at creativesafetysupply.com/5S. The thermostat that runs the heating and cooling system in the building then goes up. And that can trigger the starting of the HVAC system, which would be the heating, ventilation, air conditioning system that launches the cooling system that operates. And those are going to be based on triggers or settings that have been programmed in to kick in at a certain point. So what are the set points for when does that system kick on, and what is the target temperature that they're going for? That should be looked at and talked about. When the heating system kicks in and the cooling starts, what is the source of the cooling? How is it being cooled? Is it an efficient system? Is it an older, outdated system? We could look at that. And then when that coolant is created, that cool air, how does it get through the building? Is there a fan blowing it through? And what do the ventilation systems look like? And does it go through that ventilation system smoothly, or is there losses from leaks and air places where the air can escape out? And then there's vents and filters that it has to go through. So when it comes out into the workspace, it's going through probably a filter of some sort. What kind of filters are in place? And then what are the clothing attire that the employees are wearing in that area? If they're wearing pants and a long sleeve shirt, then they're going to want to have the air colder than if they're wearing shorts and a t-shirt. All right, so, and then just general employee preferences are going to be part of this as well. So trying to understand, what are people looking for? What do they want? And that's going to vary by individual in some cases. And then also looking at, is this system running when it's supposed to be running? So when it kicks on and it's hot, is anyone even there? So are we cooling a space where no one's working, or it's a weekend, or it's a evening? And so are we even running the system when it's supposed to be running? So looking at setbacks and when the system kicks on and off during the weekends or evening times, depending on occupancy and who's there. And then when it's coming out, is it heating and cooling the right spaces? Is it pointed in the right direction? Is the ventilation directed towards where the employees are, or is it directed to an area or zone that no one's there? So it's not really effectively directing the cooling to the right areas. And then looking at the building itself, are there gaps under the doors? Are there gaps in the windows? Are there holes in the building itself where air is easily escaping, and so it's not doing its job? So that's what you have control over in your building. It's not just out of your control because it's temperature related. It's how does your building react and adjust to the temperature fluctuations. And you can do this in the wintertime as well. You've got cold air coming in, and it goes through a very similar process. And it might kick into a different system. You might have a different energy source. You might have a different heating system. But there's a lot of similarities on how that might work. And so in the regression analysis, what we'll do is first try to figure out what are the key drivers. If I see the employee count is very important, then I know that there's a lot of employee behavioral things that we can do that can have an impact on energy usage. So we'll talk about things like shutting down your computers and shutting off lights and getting rid of personal cooling and heating systems in your offices, and looking at how hot water is being used, stuff like that. If it points to temperature, then that analysis will point me to these building infrastructure type questions. If it's more about production, then we're going to look at the manufacturing equipment or the office equipment and servers, and we're going to look at how are those being managed, how is energy being consumed on those devices, and is it being done as effectively as it can be. So if your company is doing some stuff around sustainability or looking to improve on their energy consumption or reduce their energy usage, let me know. I'd like to help walk you through the type of analysis I usually go through on this. I can explain how the regression is done, or I can help you do the regression analysis. So basically what that model creates is an equation. And the equation gives you a prediction of how you'll consume electricity going forward. And that allows you to then decide, here are the areas where I can make the most impact, because then I can lower the consumption. So for example, if temperature makes up 50% of your electricity usage, then anything you do in the building to lower the impact will help you lower it from 50% maybe down to 40% or 45%. And the more additional things you do, the more you can lower it more and more. And at some point, you'll actually mess up the model so much that you have to create a new model, because that old model is based on the old methods and old system. Think about processes a little differently, especially if you're involved in some of these sustainability type of activities. Think about the natural environment and how it goes through processes. And how does your building handle the heating and cooling that comes at it? And what does it do with it? And if you walk through that as a process map, I think it'll make a lot more sense to you on how to identify opportunities with your improvement team that you put together. And I would encourage you to get the facilities and maintenance and environment, safety, health, and production teams and office workers, get them all together as part of that team. We usually call that like a green team. And they can help kind of look at it from their perspective, from their department's view, and get a holistic view. Hope that makes sense to you. So let me know if you have any questions. Love to help you out. Thanks.
Lean6sigmadefinition.com has a list of glossary items about popular process improvement terms, along with the history of Lean and Six Sigma methods, and key influencers like Dr. Edward Stemming, Henry Ford, Taiichi Ohno, Shigeo Shingo, and many more. You can also learn how to access affordable Lean and Six Sigma training and certification. Visit Lean6sigmadefinition.com.